this problem, we want to find the focus and directrix of the parabola with the given equation and then graph it. So we got x squared equals negative 8y. Well, we have to see which formula it matches first. Remember, we got two formulas. One where the square root is on the x, and one where the square root is on the y. In this problem, the square root is on the x. So we're going to use the top formula. So we use these. So our standard form is x minus h squared is equal to 4p times y minus k. Now if we can get it in that form, then we can apply these formulas. So the x squared here we're going to rewrite as x minus 0 squared. You could also do x plus 0. But this says, standard form says it has to be x minus a number or x plus a number squared. Now over on the right side, we need a parentheses before a y. And you can always create a parentheses before your y by factoring out whatever number's in front of it. So we'll factor out a negative 8. So then we've got x minus 0 squared. And we want to rewrite negative 8 as 4 times something. This one's pretty easy. 4 times negative 2. And the y, we want it to be y minus or y plus a number. And if you just have a single variable, you can always do y minus 0. Now this is in standard form. So our number that's with our x is our h. So this is h. And it's going to be opposite sign. Though 0 doesn't have a sign. So h is 0. Whatever number's inside the parentheses here is our p. So we got p is equal to negative 2. And whatever number's right here is going to be our k. And it's usually opposite sign. K is going to be 0. So our vertex is hk, no matter if we're using top or bottom formulas. That doesn't change. Now our focus. Remember, we're using top formulas. Tells us our focus is h k plus p. So h k plus p. Well, h is 0, comma, k is 0 plus p, which is negative 2. So we're going to have 0, negative 2. And that's our focus. Our directrix for our top formulas are y is equal to k minus p. Well, k we said was 0 minus p, which was negative 2. So we got negative negative, so we got y is equal to positive 2. Yeah, I think they're wanting us to graph it. They graphed it. Okay. Vertex is 0, 0, which is right here. Our focus is 0, negative 2. So there's our focus. Our directrix is y is equal to 2. So that's our directrix. Now the vertex should be exactly in the middle of those two, so that's kind of a check to see if you did your basic math right. Now we want to drop a point somewhere. Like I drop a point right here. Now look at the distance from my point to the directrix and distance from my point to the focus. They should be the same. So I start moving it out until they are the same. Doesn't matter where you put it, as long as they're the same. That's probably as good as I'm going to get right there. Again, the distance from the focus to that point should be the same as the distance to that point to the directrix, forming a 90-degree angle. We'll drop another point. And again, I'm eyeballing this. I'm looking at the distance from my focus to directrix. Let's say about right there. That distance from the focus to that new point should be the same as the distance from that point to the directrix, forming a 90-degree angle. Now once you get two of them, then you know a parabola's got a curve to it, so you can graph it like that. And by symmetry, our other side will look like that. And that's our answer.